Hello everyone. Welcome to the course on data structure and algorithm. In this video we are going to see a very interesting topic, recursion. So first let us try to understand a normal function call that we make in our C or C++ or Java programming. So if this is our main program and if I am having two functions, function 1 and function 2, alright, so how the actual function call works. So for example, this is my function 1 and function 2. So the execution goes something like this. First, all the statement before function 1 gets executed in main, then the control is transferred to function 2 and all the statements within function 1 are executed and then it comes back to main. Then all the statement between function 1 and function 2 gets executed and then the control is transferred back to function 2 and all the statements within function 2 will be executed and then it will go back to the main program and then rest of the statements. So this is how the normal function call works. But in case of recursion it is little different. In case of recursion, the function calls itself. For example, this is my main function. So from main I am calling main itself. So it goes like, say, for example, another function is there, function 1. So within the function 1 I am making a call to the function 1 itself. So this is just an example of a recursive function call. Function calls itself is called a recursion. So this is the simple definition of recursion. Function calls itself. Now because in our previous case one may foresee that if it is like that, if I call main from main, it may go to infinite loop. Alright, so in that case we need to have terminating condition so that this infinite loop is prevented. So terminating condition is a very essential part of any recursive call. The second thing is this recursion is not applicable to all problems. So we'll see, we are going to see 4 different problems in this video. So all those problems which there are some specific problems in which the recursion is applicable. So it is not applicable to every problem. Now what are the benefits? The benefit is the code will be shorter. Alright, the overall program will be smaller, but the difficult part is it would be little complex to understand. So this is about basic recursion. Now let's see the example so that we'll understand recursion. So the very first example is a factorial, which is a very common example, right? So we know that 5 factorial is 5 into 4 factorial. So while calculating the factorial itself, we need factorial. So this is a kind of example wherein recursion is applicable. Same way, if we have x raised to y, we know that it is x into x raised to y minus 1. So this is also power kind of. Fibonacci series is something like wherein we have two terms, 1 1, and then I'll be adding these two terms and I'll be generating the next term. So then I'll be adding these last two terms and I'll be generating 3. Then I'll be adding 2 and 3 and I'll be generating 5. So likewise this Fibonacci series, this is also this can also be implemented using recursion. And we have one more example that we'll see, a Tower of Hanoi. Alright, so let's take all these example one by one. Let us start with the example number 1, factorial. So we know that in case of factorial, n factorial is n into n minus 1 factorial. So let's take some numbers. So if it is 5 factorial, it is 5 into 4 factorial. So 4 factorial is nothing but 4 into 3 factorial. Now 3 factorial is nothing but 3 into 2 factorial. Same way 2 factorial is nothing but 2 into 1 factorial. And we know that 1 factorial is the terminating condition. So 1 factorial is 1. And then when we go back, it's 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5. So that will give me the answer 120. So this is our terminating condition, 1 factor. So this is very important as we have discussed. So terminating conditions are very important. It would prevent you to go into the infinite loop. Right. So now let us try to implement this using C programming. So we are having a function factorial wherein we are having one argument. So that is nothing but, for example, if I wish to calculate 5 factorial, so I'll be passing 5. And it will return something. So it will return answer. So answer will be 120. Answer of 5. So we are going to take both as integer. Now in this case, Let us try to understand, let us make a function call. Say answer equal to fact of x. That means I'm calling fact function with x as argument. So x is nothing but 5. So that 5 is thrown as an argument to function. So now this n becomes 5. So now n is 5. So before entering into this, most of the recursive call, we first make that condition check whether n is less than or equal to 1. In our case, 5 is less than or equal to 1. No. So in that case, it would return 5 into fact of 4. So 5 into fact of n minus 1, that is 4. So it will again jump back to this function. So let us see the execution of this one. So this is my main program. So from main program, the statement is answer equal to fact of x. So answer equal to fact of x. That means I'm calling function fact. So I'm calling function fact and the value of n equal to 5. So it will not go over here in if, and it will go to else, wherein else it is return n. N is 5 into fact of 4. But it will not return over here because it needs to calculate fact of 4. So now again it will jump over here, again it will jump here, and now the n equal to 4. So next is what will happen, again it will not go over here and it will go to else. So it is return n is 4 and fact of n minus 1. So n minus 1 is 3. So again the function is called, but this time n equal to 3. So again it will not go into this condition and it will go to return 3 into fact of 2. Again when we go to fact of 2, again it will not go into this if condition and it will go to return 2 into fact of 1. Now we need to understand from here what will happen. Now this is fact of 1. So now when it is called, now this time n will be 1. N will be 1, and now this condition will be true. So look at this. Now n is equal to 1. So this condition is true. So now what will return? It will return 1. So when it will return 1, so it will go to this particular thing because this was called by this. So this return 1 will be over here. So now the answer of this entire fact of 1 is equal to 1. So that 1 multiplied by the previously waiting 2. So 2 multiplied by 1 is 2. So that 2 goes to here. So now that is 2 and multiplied by previously waiting 3. So 3 multiplied by 2, that is 6. That 6 goes to here because it was called by this. So that 6 multiplied by previously waiting 4, that is 24. 24 goes to this. So that 24 multiplied by previously waiting 5, that is 120. And that 120 goes to fact and again it will copy to answer. Alright. So answer will be 120. So when we print answer, it will be 120. So this is how the factorial is calculated using recursive call. You can see this code at this GitHub repository. Let us take the another example, say x raised to y or base raised to exponent. So it is base raised to exponent is equal to b into base raised to exponent minus 1. So if we have something like 2 raised to 5, it is 2 into 2 raised to 4. 2 raised to 4 is 2 into 2 raised to 3. 2 raised to 3 is 2 into 2 raised to 2. And 2 raised to 2 is 2 into 2 raised to 1. 2 raised to 1 is 2 into 2 raised to 0. So 2 raised to 0, anything raised to 0, that is our terminating condition, because we know that anything raised to 0 is 1. So that is 1. So look at this. This is our terminating condition, and once this is done, you can multiply this 2 into 2 into 2 into 2 into 2. So the answer will be 32. So this is something what we want to do with C programming. So let us write a C program. So over here now we are having function power with two arguments, because first is base and another is exponent. So if I want to have 2 raised to 5, so I'll be writing base equal to 2 and exponent equal to 5. So it is base raised to exponent. So base is copied into b and exponent is copied into e. So now let us try to understand how it gets executed. So first, this statement in main, answer equal to power b raised to e. Alright, so this, what is the value of b? B is equal to 2, so that is copied over here. E is equal to 5, that is copied over. So b is equal to 2, e is equal to 5. Now whether e is less than 0? No. So this if will not get executed, and it will go to return. Now b is 2, b is 2 into power this b, that is 2 raised to e minus 1. E was 5, so e minus 1 is 4. So 2 into power 2 raised to 4. So again now it will go to here. So b equal to 2, e raised to 4. So return 2 into power 2 raised to 3. So again it will go to here. So it will return 2 into power 2 raised to 2, because it is, this thing is getting decremented. This thing is getting decremented if you carefully look at this. Alright, because we are having over here we are having e minus 1. So initially it was 5, so now it is 4, now it is 3, now it is 2, so it will go, now it is 1, and now it is 0. So the moment it reaches 0, what will happen? It will come here. So e is equal to 0, yes, so it will return 1. So if this is not visible, simply you can see that there is 1. So this will return 1 over here. Now 1 multiplied by previously waiting 2. So 2 multiplied by 1 is 2. That is returned here. So now this 2 multiplied by this previously waiting 2. So that is 4. That is returned over here, 4. 4 multiplied by previously waiting 2. So 2 multiplied by 4, 8. That goes here. So 8 multiplied by 2, that is 16. 16 goes here. So 16 multiplied by previously waiting 2, that is 32. 32 is assigned into answer. So that 32 will be printed. So b is 2, e is 5, and this 32. So our answer is 2 raised to 5 is 32. 2 power 5 is 32. So this is the second example of recursion. Now third example is Fibonacci series. So Fibonacci series is very simple, wherein we start with the first two terms 1 1, and then next terms are calculated with last two terms. So 1 plus 1 is 2, then 1 plus 2 is 3, then 2 plus 3 is 5, then 5 plus 3 is 8, and then 13, then 21, then 34. Likewise it will keep on going. So this is how you generate Fibonacci series. Now let us try to implement this using recursion. So we start with two terms, the first term and second term, t1 and t2, and initial values of t1 is 1 and t2 is 0. Right, so t1 is 1, t2 0, and t3, how we are going to calculate t3? It will be the addition of t1 plus t2. So t1 plus t2, so 1 plus 0, so that is 1. And then what are we going to do? So t2 we are going to put it in t1, then t3 we are going to put it in t2. Alright, so the new value of t1 is 0, the new value of t2 is 1. And again we'll repeat the same thing. Again we'll add these and these, so t3 will be 1. Again what we are going to do, t2 we are going to put in t1, t3 we are going to put in t2. So new value of t1 and t2 are 1 1. So now again add them together and put it in t3, so t3 becomes 2. Again we are going to put t2 into t1, so now it is 1, and t3 into t2, so t2 is now 2. Now again t1 and t2 are added together and answer is put in t3, so t3 is now 3. Likewise you can continue, the t2 is copied into t1, 2, t3 is copied into t2, that is 3, so 2 plus 3, that is 2 plus 3 is 5. So likewise if you carefully look at it, so if you print like this, so this 1 1 2 3 5, so this is the Fibonacci series. You can keep on continue. Okay, how many terms? For example, this is for 5 terms, you can go for 50 terms or 100 terms. Right. So let us try to see how this is implemented using this C programming. So now we are having one function Fibo with 3 arguments. The first 2 arguments are t1 and t2. T1 and T2, and the last argument is total terms, because we know Fibonacci series is infinite. So how many terms? For example, you want to start it at 5 terms or 10 terms or 20 terms, how many terms you want to print on output. So we are going to pass 3 arguments, the T1, T2 and total term, that is TT, total term. Alright. Now let me pass this, let me call this Fibo series. So T1 is 1, T2 is 0, and because I want 5, I want total 5. So T1 equal to 1, T2 equal to 0, and total terms equal to 5. 1, 0 and 5. 1, 0, 5. Now let us see how does it go. So first from main it will be Fibo 1, 0, 5. So now if you look at it, so T1 will be 1, T2 will be 0, T1 will be 1, T2 will be 0, and total terms I have written TT. So total terms equal to 5. Now print T1 and T2. So T1 and T2, so 1 plus 0, so that 1 is printed. So the first thing. And then what we are doing, is the total time is less than or equal to 1? No, in this case it's 5. So what we are going to do, so this T1, that T2, that we are going to pass it in T1. So T2 is copied into T1, and a T1 and T2, that is in fact nothing but T3. So that is copied into T2. And now because one term has already printed, so we are going to minus it. So next time T1 equal to 0, T2 equal to 1, and total term equal to 4. Now again 0 plus 1, that 1 is printed, and then now I am going to copy T2 into T1, T1 plus T2 into T2. So 1, 1, and total term is decremented by 1. So now is 1, 1, and 3. So 1 and 1, that 2 is printed, and then now I am changing, I am copying T2 into T1 and T3 into T2. So likewise, just keep on doing, keep on going, and when this total term is less than or equal to 1, all right, at that time what we'll be doing, we'll be returning. So we'll be returning, but we are not returning volume value, we are just going back. But by the time 1, 1, 2, 3, 5 have already been printed. All right, so this has already been printed. So in output you'll get this 1, 1, 2, 3, 5. Right, and you can get this code on this link of the GitHub repository. And the very last example of recursion that we will see in this video is Tower of Hanoi. Tower of Hanoi is a very excellent example wherein we are having 3 poles. This source pole, then we are having destination pole, and then we are having a temporary pole. So using this temporary pole, I wish to transfer all these piles in such a way, all this disk in such a way that will be having the largest disk on the bottom, then the middle one, and then the smallest one. So this is what we wish to achieve. Now let us see one by one. So temporary pole we will use for the sake of intermediate operation. So first I am transferring the green one, the smallest one, into destination pole. Then I am transferring the blue one into temporary pole. Then I am after this I am transferring green on the top of the blue one. So this is the situation. Then I am transferring the largest disk number 3 on the destination pole. Then I am transferring disk number 1 on the source pole. Then I am transferring this disk number 2 on the destination pole, and at the end I am transferring disk number 1, the smallest one, on the destination pole. So you can see we started from this pole source, and now we ended on this one, destination. So this has been, and we have not violated any rule, means you cannot take the middle disk out, you can always take from the top only, and you cannot put the bigger disk on the smaller one. So we have not violated any rule, and we have transferred all. Now this is for n equal to 3. This is for n, total number of disks are 3. You can have it for n equal to 4, n equal to 5. So we can have some recursive mechanism that will convert everything. So let us try to write this code. This code is very simple. If you look at this, the code is very simple. So what we are doing, we have made a function TOH. TOH is Tower of Hanoi, right? And what we are passing, this 3 characters: source, destination, and temporary. All right. So look at this very carefully one by one. If you run this program, you'll get the complete set of output. That source to the moving disk number 1 from source to destination, moving disk number 2 from source to temporary, moving disk number 1 from destination to temporary, and likewise. And if you follow these steps, what you will get at the end, all those disks from the source pole will be transferred to destination pole. Now how does it happen? Let us see programmatically. All right. So initially I am having this this S, D, T, and N. N is nothing but the total number of disks. So this is something like TOH 3. 3 is this N, and then source, destination, and temporary. Now look at this. So what we are doing? So now what we are doing is, this is copied. This is copied. The source is copied into source. So this source is copied into source. Now this destination is copied into temporary. This destination is copied into temporary, and this temporary is copied into destination. So this temporary is copied into destination. So now this is the case. So now I am having S, T, D. Now I am having S, TD. Now you can see, now we have two things. See, now this n is decremented by 1, n minus 1, n minus 1. So we are calling two functions. So if I call this 1, then this is 1 and this is 2. And in second number, you can see that, you know, this source is copied into temporary, alright, and this destination temporary and source. So look at this. Now in between these two are two different things, 1, 2, but in between these two things, because from here it will go to the function call again. So from here, from number 1, it will not come to function number 2. So let me remove all this stuff for a while. Now look at this very carefully. So this is my statement 1, this is my statement 2. So this is my statement 1, this is my statement 2, but it will not go to statement 1. Even this is my statement, let's say X. So it will not go to statement X also, because from statement number 1 it will go to this loop. Okay, so now from here you can see that source is copied into source, then destination is copied into temporary, and temporary is copied into destination. So destination and temporary are swapped. Alright, so now you can see, and then n minus 1. So now n equal to now 1. So again, now this is 1. Again for this, this will not execute. Now what will happen? From here it will swap this s dt. So the n equal to 0, n equal to 0. So for this, now between these two stuff, you know, because this is the last term, you know, this is our terminating condition, n equal to 0. So if it is 0, what will happen? It will return. So it will return means it will come back here. And from here, now this part is over. Look at this part is over. So it will go to this condition. And in this condition, what is written? Source to temporary. So source to temporary. So this is source and temporary is copied into destination. So S and D. So you can see over here S and D. So moving this number 1 from source to destination. Now then again come back to the main part. And in main part it is S and T. So in main part it is S and T. Now once this part is over, once this whole recursion is over, what will happen? So this whole thing is over. Whole thing is over. Alright. So now it will print, it will go to this part. It will go to this, because this number 1 is over, printing is over, and now it will go to the second number. In second number also, when this is 0, it will come back and it will print the D to T. So it will print D to T. Now this whole part is over. Whole part is over. Matlab, in this case, let me erase everything. Now let's come back to the original one. Original one is source to destination. Source to destination. So source to destination. So that part is printed, and now let comes this one. So again this whole thing is repeated for this step. Whole thing is repeated for this step. Now you can come back. So this temporary to source, then temporary to destination, and then lastly source to destination. Source to destination. So if you follow this step, all those disks from source will be transferred to destination. Alright, and you can get this code over here on this repository of GitHub, and if you want you can even change, and you can have 4 disks or 5 disks, and whole program will work for 4 and 5. Right, so with this we are concluding the topic of recursion, and in our next video we'll be taking the next topic, that is queue. So thank you very much all of you for being here.